Welcome 7th graders. I can evaluate algebraic expressions using order of operations. This is your target for this video lesson. If you're following along with Glencoe Course 3, it's going to be section 1-2 starting on page 29. Make sure you take good notes and ask questions within your notes so that you can bring those to class and have the best math experience. This is a vocab-rich chapter, so I want to talk a little bit about what you should expect when doing algebra, now that you are in pre-algebra. So there are some words that are correlated with algebra, and you should know that algebra is the branch of mathematics that uses letters in place of numbers. These letters that are in place of numbers that represent unknown values are called variables, and I've listed here just a couple letters that are options to use. You'll also see M, you'll see Y. A letter you generally won't see is O because it looks a lot like a 0. Something else you've been seeing are numerical expressions. Numerical means number. And so these numerical expressions are just really number sentences that have numbers and operations. There's no equal sign. That would be called an equation. This is an expression. It does not have an equal sign. So numerical expressions have numbers and operations. Whereas now that we are into algebra, you're going to see algebraic expressions. Again, algebra implies that there's going to be some variables involved. So what's different about an algebraic expression from a numerical expression is that there are now variables, numbers, and operations. So you'll have all three. Finally, you're going to hear evaluate a lot. I'll be asking you to evaluate expression. Evaluate means to find the value of. Notice that is in the word. So if I were going to ask you to evaluate the numerical expression of 3 plus 2, that really means to find out that the value of 3 plus 2 is 5. So find the value of. Definitely some things that you want to put down onto your vocabulary sheet, write down in some notes, and just really, when you're reading directions, make sure you understand what they mean. Really important, from this moment going forward, you have to think about how is multiplication shown in algebra. Generally, you have seen an x used for multiplication, 2 times a number, but now x is a letter. It's used for a variable that's in place of a number unknown. So we are no longer going to use x for multiplication. We're not using it. Because this really could be 2 times a number times another number. This looks like 2 times 2 different numbers, and that's not what we want. So we're saying, how can we write 2 times n? How else can it be written? You can show multiplication by placing a number next to a variable. It's going to be called your coefficient. You always put the number first, not the variable. You could put 1 in parentheses and next to each other to show multiplication. Or you can use a dot, not a decimal. It's hard to draw. A dot or an asterisk, which is like a star in between, kind of tough with this pen, to show multiplication. But we will no longer be using the x for multiplication. Some other things to keep in mind. Expressions such as 7 to the 2nd power, or 7 squared, and x to the 3rd power, or x cubed, these are called powers. This as a whole is called a power, those two separately. What powers do is they represent repeated multiplication. To kind of give you some insight into that, hopefully you know that if I were to do 3 plus 3 plus 3, that can also be represented as 3 times 3. Multiplication is used to show repeated addition. Powers are used to show repeated multiplication. So just a step further. So when we see 7 squared, or 7 squared is 7 times 7, which is the same as 7 squared, or read as 7 to the 2nd power. X cubed, x to the 3rd power, is x cubed, which really shows that you're multiplying x by itself 3 times. So the larger number is your base, and that smaller number is your exponent. I sometimes like to show this as a capital B and a little e. Okay, so the exponent tells you how many times you're multiplying the base by itself. That's what a power is. So on to evaluating algebraic expressions. Okay, so remember parentheses, little study tip here. Parentheses around a single number do not necessarily mean that multiplication should be performed first. Remember that we go left to right. So here we're going to be given expressions when x and y or any other variables have a value. And this just kind of walks us through some steps with some words to guide us through. So if we were asked to evaluate this expression given the values of these variables, first thing we would do are replace the letters with the numbers that were given, shown here. Then we would perform the operations using PEMDAS. Okay, so we're going to use, obviously, parentheses first in this case. Continuing with PEMDAS, then it looks like in this one we would do the powers and then multiply. So again, following order of operations. And now we have a value. We evaluated it. Again, in the second example, same type of thing. We're given a value for g. So it was plugged in, evaluated using order of operations, powers before the rest. Then it looks like multiplication came. Then there was subtraction left to right. Evaluated the answer. So let's give a couple a try here. It looks like we're asking to evaluate, find the value of each expression when c is 3 and d is 7. So using this first one, I'm going to rewrite it 6c plus 4 minus 3d. And c was 3, so we're going to plug that in. So 6 times 3, notice I used my dot, plus 4 minus 3 times d, which was 7. I used parentheses that time. So then there's nothing within parentheses if I was going to use my PEMDAS checklist. Nothing in parentheses. There's no exponents. There's multiplication left to right. So I do that. 6 times 3 is 18. Rewrite my problem. There's more multiplication. 3 times 7. So I rewrite 18 plus 4 minus 21. So I did multiplication. There's no division. There is addition and subtraction. Do what is left to right. So 18 plus 4 would be 22 minus 21 for an answer of 1. Again, notice I showed all my work and made a nice V going down. You can try B as well. So we're going to replace the values. So we do 4, replace D with 7, C with 3, and square that, and add 1, rewrite it. Again, order of operations, we are going to do our parentheses first. So I'm going to do what's in here. So I rewrite the rest, 4, 7 minus 3 is 4, squared plus 1. There are exponents, so I do that next. So 4 times 16 plus 1. There is multiplication. I almost did 48, but that was close because I checked myself and I said, nope, 6 times 4 would be 24. That actual number should be a 64 plus 1 for a final value with addition of 65. Notice I caught my mistake. Make sure you try to focus in and do that as well. You can give the next one a try. If you have any questions, bring it to class. There's going to be some where you see division or you see a numerator and a denominator. What you need to know is that a fraction bar is a symbol for division. Okay, so when you see things like this, you want to assume that the top and bottom are really separate expressions, and you kind of treat them like they all are in a group, and you cannot divide until both the top and bottom have a value. So we're going to start by evaluating each expression with the given values. So we plug in for P. Looks like P is 5. Multiplication. All over 8, we have P again, which is 5. So it's like I'm treating each one as separate parts. So on the top, I have multiplication here. So I get 15 minus 6 all over 8 minus 5. I have subtraction both the top and bottom. So on the top, 15 minus 6 is 9. 8 minus 5 is 3. 9 over 3 simplifies divided to 3. Over here, we're going to do the same thing for example E. Plug in what we know. 4 times Q, which is 12, over Q, which is 12 again, plus 2 times the sum of P, which is 5, plus 1. Notice again, I've just replaced the variables with their values. Now I'm going to work on the top and the bottom. The top is multiplication, so I do 4 times 12, which is 48, over, the bottom has parentheses, so I rewrite 12 plus 2 times 6. So on the top, we're kind of done at 48. On the bottom, we have multiplication, 12 plus 12. We have addition, so we add those together. We have 48 over 24, which simplifies to 2. Again, you can give this one a try. Very good. A couple other things. I know 1, 2 is a big section. We're going to look at properties just so we know what kind of rules are happening and what's true for all situations. So there's a couple properties or rules that are always true. And I have some different things just to kind of get you to understand what the words mean and associate with them. So you want to write these things down. The first property that applies to addition and to multiplication is called the commutative property. The way I remember this one is that your parents drive to work. That's called their commute. I'm going to draw you a little picture. And when they're commuting, they are actually moving. Okay? So this one shows, in algebra terms, A plus B is actually the same as B plus A. 6 plus 1 is 7. 1 plus 6 is also 7. 7 times 3 is 21. 3 times 7 is still 21. So what that means is the numbers move, but the value stays the same. So commutative means the numbers can move. Associative, I like to think of associative as who you are grouped with, who your friends are, who you associate with. So who you're grouped with, notice here the grouping is around B and C, but then it changes to A and B, but the value is still equal. And that's still true for addition and multiplication. 2 plus 3 plus 8, which is 11, is 13. 2 plus 3, which is 5, plus 8 is still 13. The groupings change, but they remain equal. That is how they associate. We're not going to focus too much on distributive right now. We're going to look at identity. And I like to think of identity as your identity is that you stay the same. You stay yourself. And this is also true for addition. You could add 0 to any number, and it should stay the same. Add 0 to any number, and it stays as its identity. Same thing, you can multiply any number by 1, and it should stay in its identity. So identity means it stays the same. Multiplicative identity, additive identity. So here you can determine which is which. How can you say? Just like here, example 4, it says, to describe this, and they notice that the grouping changed, but the value stayed the same. So the order of the numbers and variables did not change, but their grouping did. Since their grouping changed, that's the associative property of multiplication. So if we were to name the property down here, I noticed that X and Y changed order. There's no groupings, the operation didn't change, the variables moved. So since the variables moved, but the value stayed the same, this would be the commutative property of addition. The second one, 3x plus 0 stays as 3x. We added 0. This is the additive identity property. Kind of writing backwards. You may be asked to find a counterexample. That just means, say if it's true or false, if you read a sentence. Is it true or is it false? Division of a whole number is commutative. So we say, okay, division, whole numbers, is it commutative? Commutative, we need to know it can move and stay equal. So they give an example. Should 15 divided by 3 be the same as 3 divided by 15? Well, we know that 5 is not equal to 1/5. So the counterexample would be this. And though since it's not commutative, this sentence was false. A little bit of a longer one, ladies and gentlemen, but a lot of important information, a lot of good information. Pause where you can, write questions where you can. Definitely take notes that are going to help you in class.